So we've just talked a little bit about, and I gave you a cheat for 3C, which is actually covered in 3D. Okay, so it's the remainder and factor theorems. So we just worked out, okay, over here, that if we're dividing x cubed plus x squared plus x plus 1 by x minus 1, we get a remainder of 4. If we substitute in 1, so we change the sign, we substitute in 1, we actually get a polynomial value of 4. So they're tied together. That's called the remainder theorem. Okay, so the remainder theorem is substitute what would you call it? I'll just put number in remainder of x minus number divided by polynomial equals p number. How's that? Clear as day.
Yeah.
Alright, so it's actually not that bad. To do it, you substitute the number in. Okay, the remainder, when you divide x minus number into that polynomial, okay, is the same as the p of the number. Okay, so that's that substitute number in.
Yeah.
Okay, so in the last bit over here, if we bring it back, okay, our number was 1. When we divide by x minus 1, our remainder is 4. When we substitute 1 in, our polynomial value is 4. Okay, so they're tied together. So that's written in words very poorly, but it is written in words. Okay, so how does that tie in to the factor theorem? Okay, what do we know about a factor of a polynomial? What should the remainder be?
0.
Right, so if p of the whatever number we're putting in actually comes out to 0, then x minus that number is a factor. Okay, so is x minus 1 a factor of x cubed minus plus 2x plus x plus 1?
No.
No, because it's got a remainder of 4. And it's got a value of 4 when you substitute that 1 in. So, for it to be a factor, your remainder must be 0, and you can work that out by substituting in that number. Make sense?
So by substituting in 0.
No, by substituting whatever number.
Oh,
So, for
okay.
example, we can work out, so if we have a look,
So if it,
at question 4, okay, we've got a polynomial, I have to shift that up, we've got a polynomial x cubed plus 2x squared plus minus 11x minus 12, okay, and we're asked to find out which of the following are factors. We've got x minus 1, x minus 3, x plus 1, and x plus 2. Okay, there are 4 questions. So, how do we work out which ones of them are factors? Change the sign
change
and substitute it in. So for this one, we're going to substitute in 1. Okay, so 1 cubed plus 2 times 1 squared minus 11, I should be using my brackets, sorry guys, minus 12 is 1 plus 2 minus 11 minus 12. 3 minus 11 minus 12
No.
is 3 is negative 8, negative 20 I think. So is it a factor?
No.
No. Okay, so let's grab another colour. What am I substituting in?
3.
3.
So I substitute in 3. So 3 cubed plus 2 times 3 squared minus 11 times 3 minus 12. 3 cubed is 27. 3 squared is 9 times 2 is 18. 11 threes are 33 and another 12. So if we've got 27 and 18 is, what, 35, 45. 33 minus 12 is minus 45, so we get a 0. So is x minus 3 a factor?
Yes.
Okay, see how that works.
Yeah.
Now I'm not going to do the other two. You guys can do them on your own. Okay, so question 3 talks, and it's a little bit harder, it's a little bit more in depth. X cubed plus kx plus 1, when divided by x plus 2, the remainder is negative 19. What's k? Okay, that's what the question is asking you. Okay, now this is a fairly simple one if you just think a little bit. So, what's the first thing I need to do? I need to substitute in -2. Okay, so P of -2 equals -2 cubed plus K times 2 plus 1. So, -2 there. So, -2 cubed is -8 minus 2K plus 1. If we simplify that down even further, -8 plus 1 is -7 minus 2K, and that equals what?
Don't ask us.
19, minus 19.
Okay, it equals -19. How do I know?
You can find out K.
Because I'm trying to find what K equals.
Oh, so you
Okay,
have minus
so my remainder, when I substitute that in, is -19. Now I just rearrange this to get K on its own. So I'm going to take 7 over the other side, and I get -12 equals -2K. I take the -2 over the other side, and I get 6 equals K.
Yep.
Okay, so it's not a great deal harder than anything else. It just takes that little bit of extra step, a little bit of extra thinking.